Lesson 7.3, Lesson 5, the distance formula. And what we're going to show you here, since the distance formula is a formula that uses a radical as part of its calculations, it's an application of work. It's also something that you will see on the MCA possibly, so we want to make sure you understand how to use this formula for that too. So take a moment to pause the video. Please copy down the distance formula that I have here, and then you can restart the video. And I'll show you how the formula was created and how it's used. Okay, using our distance formula, and it's based upon the Pythagorean theorem. So that's why I already have written here a squared plus b squared equals c squared. And I'm going to show you how we do that. Here I have 2 points marked here on the graph. I have one up here, and it's located at the point 2, 9. So this is 2, 9. And I have another one down here at, whoops, I have another one down here at 10, 3. All right, so how do we deal with this? Well, notice I said the Pythagorean theorem. That means a right triangle. So let me draw in a triangle for you, and I'll show you how this is used then to calculate the distance between 2 points. And the reason we need this is, for example, if you look here on this line, it cuts diagonally through the squares. If it was going straight up and down or straight across, I could certainly just count the spaces and know the distance. But in this case, I'm going diagonal. So what we do and what's done is that we change this and we make it a right triangle, and we do some work with the Pythagorean theorem. So the first thing is I'm going to create a right triangle, and the first side is drawn from the first point on the left, and it's drawn until I'm across from the second point over here on the right, and then I'll draw another line from the corner over to the second point. And since this is a right triangle, I will put in the right triangle symbol to remind me that that's what it is. Now I'm going to then use, in this case, since I have graph paper, I could certainly just count spaces to help me figure that out. So, and how would I count them? Well, I would take a look. I have 1, 2, 3, 4, 5, 6 spaces that I go down here. So one way to look at this is this on this side is a -6. And then on the right side over here, I'm sorry, not on the right side, but underneath, I'm going over 8 spaces. So how do we apply this then to the Pythagorean theorem? Well, in the Pythagorean theorem, we have leg A, we have leg B, and then we have our friend the hypotenuse C. So if we knew what these were, since we could count them, we would put in, we'd have a down 6 and squared, and we would over 8 and squared equals c squared. And we would follow our method of calculating using the Pythagorean theorem. So then how was the Pythagorean theorem used then to create the distance formula? So let's take a look at what we did, what I've done here. So to get from this dot on the left, our new dot, our old dot, going to the new dot on the right, how did we get this far? Well, to get this -6, this is on an x line. This is on the line of the 2 line for x. I have to look at how much change there was in y, and I have to look how much change there was in x, and that's what the distance formula will use. Here you have an x minuses and you have some y minus. So it doesn't matter whether I put x2 minus x1 before y2 minus y1, either one, either order, it won't matter. I'm doing addition. So as we write these in, I just have to be consistent with how I write them. To follow the formula, I'm going to deal with the x movement first. So we need to figure out how far have we moved across from the dot on the left to the dot on the right. Well, when I know just the coordinates, that means I have started on an x number of 2, and I've ended on an x number of 10. So what I have then is I have taken 10. What we do is we would take and say we have 10, because that's my new, I'm going to do new minus old, 10 minus 2, and I would put it in for A. Okay, now I'm sorry, it looks like I mislabeled this down here, so I should have written that. Let me change that for you. Okay, so this will count as A because we're dealing with X, and I'm following the distance formula here. So I want to make sure I have this labeled correctly for you. So I've dealt with the distance on the X first. So I've done the new 10 minus 2, and I put that in squared. If I'm following then the Pythagorean theorem, so I'm going to put a plus. If like I have here. How do we get our other leg for b? So my other leg is, well, I started at a height of 9 and I ended at a height of 3. Started at a height of 9, ended at a height of 3. Okay, so my apologies again. The new one is 3, the old one is 9. New is 3, old is 9. So how do we find that? Well, I would then take and I would do new of 3 minus old of 9. And I got to be consistent with what I do here. I said new minus old for the x, 10 minus 2. So then I have to use the same order. The new dot 3 minus old of 9. So that's why I put that here. So now I have 10 minus 2 squared plus 3 minus 9 squared equals c squared. Which now on the inside of this I would get negative 6 and I would get 8. I would get negative 6 here and I would get negative 8 and I would get positive 8 here. So I'd have 8 squared plus negative 6 squared equals c squared. Well, where the Pythagorean theorem is related to the distance formula is right at this step, is right as I substitute in. Eventually, what would I do to solve for c? I would square root both sides. I would take the square root of all of that. The square root of 10 minus 2 squared plus 3 minus 9 squared, and that equals the square root of c squared. Well, c squared would just turn into good old-fashioned c, and then I have, underneath, I have 10 minus 2 squared plus 3 minus 9 squared. So let's see, 3 minus 9 squared, that equals c. So how does this relate to the distance formula? Well, c is the length I'm after. Well, in the distance formula, it's not called c, it's called d for the distance. And let's take a look at where these numbers come from and see if we can fit that into the formula. So here I have the first coordinate. That's the old number. So that's x1. This is y1. This is the new number. That came second. So this is x2. And this is y2. So now let's substitute into where I have numbers over here. Let's substitute the x2, the y2, the x1, and the y1. The number 10, that is x2. So I would then be changing this to x2. Where does the number 2 come from? Well, that's minus x1, because I have to find the difference. How far apart are they? And then the squared is there. Where does the 3 come from? Whoops, forgot my plus sign. So where does the 3 come from? 3, y2. Now again, the 2 below, when it's called a subscript, this is just telling you here's where the number goes. It's a location. And then where is 9? That's y1. So y1 and squared. So here we are. Now here's our distance formula. It actually comes from when we subtract the distances between the x and the y on a right triangle. All right, so when you do this, when we actually find the assignment out, or to do an actual problem, then how do we actually use the formula? I'll continue the calculations from up here. Okay, so I'm going to, let's take a look at a new pair of points. Here's the assignment you're actually going to be doing here. And if you think you understand it at this point, you are certainly more than welcome to pause the video and start on this assignment here. But I will do one example here, and I'll write this down for you. If you want to pause the video, write down the assignment, that's fine. But I'm going to do one more example. So let's say I have two coordinates, 3, -4, and -6. How do I plug this into the formula? We're just going to do it like this, plain and simply put. Got our formula. We're going to say d equals, and I'm going to make a big long square root symbol here. And underneath that, I'm going to put a parenthesis. And I'm going to say, what's x2? Well, here's x2 right here, the -6. So I'll say -6. And then what is x1? Right here. So minus 3 squared plus, and here's y2, so that's 10. Here's y1, that's a minus negative 4, so I say minus negative 4, which, as you know, I could actually turn this into a what? A plus, of course. So I think I'll do that now. So when I put in a negative number into this, I don't need to write it as a minus and negative. I can actually write that as a plus. And so I'm going to make that change right now, just to make it a little easier for myself. And you are more than welcome to write it that way. Again, I'm putting it in as a plus 4 because minus and negative is like a plus. So now I start to calculate. Say my distance equals the square root of, and it's still a big long square root symbol. Negative 6 minus 3 is negative 9. So I have negative 9 squared. Some of you might be looking at this and saying, well, gee, you got a negative number under a square root symbol. How are we going to do that? Notice that you have a squared for an exponent. Think for a minute as you're watching me write this. What happens when I square a negative number? What happens when I square a negative number? That's right. Negative times a negative is a positive. So let's see what happens next. I will actually square these numbers. So I say then that the distance will equal the square root of 81 plus 196. And then I will add those two numbers together. So my distance will equal the square root, and let's see here, that would be 277. 277, square root of 277. The next thing I want to look at now is I want to take a look. If I have the square root of 277, are there any perfect square factors in there? Are there any factors that is this a perfect square itself? And to tell you, before I did the video, I took some look at the numbers, and actually 277 does not have any perfect square factors in it. So I'm just going to leave this as d equals the square root of 277. I can also actually do the square root of 277 and say then that it's approximately, and I'll bring up the calculator here. It's approximately, so I'm going to type in 277 and hit my square root function, which is right where? Where is that square root? Not x squared. Well, I'll just tell that one there. I want a square root. So the square root is approximately 16.64. So I'd say it's approximately 16.64. If I had an answer that came out, like d equals the square root of 50. You know from our previous lessons in 7.3 that I would then simplify this. This is then equal to the square root of 25 times the square root of 2. And the square root of 25 is 5, so I say d equals 5 times the square root of 2. So if you run into an answer like it's d equals the square root of 50, always check to see, can you pull out any common perfect squares? If you can, simplify those and leave it as a simplified answer. If you can't, you can then write it out here that it equals the approximate amount. Okay, so if you have any questions, feel free to bring those to me. But your assignment's right here. It's page 435, 73 to 82. Please turn that in when you get done, and be sure that you check your answers. Let me know how I can help you.